Hello everyone, and a very happy new year to all of you. This is Tanuja Kopal, welcoming you all to the first in our Tech Trends webinar series of 2013. And we will kick off our series once again discussing electronic lab notebooks, or ELNs in short. In fact, back in 2012, we started out the year discussing ELNs, and now a year later we are back on the same topic because I think a lot of people still remain to be convinced about using ELNs, and questions still remain unanswered. And as ELNs have evolved through the year, both in their features and in the applications, new questions seem to arise. And we have found that even after users are convinced that ELNs are the way of the future, there are still other questions around which ELN is right for my lab, how do I go about implementing and integrating it. So I think ELN will be a part of our continued webinar series discussion each year, and I'm sure each time we will get a sense for how much further this technology has evolved in terms of delivering on its promise. So to start us off with our discussions today and to address some of your questions, we have with us a panel of 3 ELN experts. Each of them will go over their brief talks, but then we would like to turn this event into like an open dialogue, and you can take this opportunity to ask questions, and our panelists can address your questions right here in real time. You can send in your comments or questions anytime during the webinar by typing it into the question box, and I will be receiving them on my end. After our speakers have gone over their presentations, I will bring up your questions for discussion, and our experts will offer you their perspectives on the matter. Today's webinar will also be archived on Lab Manager's website, which is www.labmanager.com, and we will be sending you the link to that archive in a couple of days. So you can certainly go and review the webinar, but please note that you will not be able to download any slides from the website. You will have to email our speakers and get a copy of the slides directly from them. So with that, let me welcome our first speaker, Dr. Philip Skinner from PerkinElmer. Interestingly, Dr. Skinner started his career as a medicinal chemist, and during that time, he took on a project to deploy ELN in his lab. And eventually, I think that was a turning point. He joined the vendor, Cambridge Soft, which is now a part of PerkinElmer. And in his current role as Director of Field Marketing, he still continues to help scientists about using ELN and how it can solve various issues in the lab. So welcome to the webinar, Philip.
Good morning, and thank you. So I want to address the question about electronic lab notebooks, do I really need one? And really turn that on its head and ask you, the audience, to think more about what are the problems and challenges you face in your laboratories, what is impeding you from doing your science, and then think about how and if an ELN can help you solve those problems. And this is actually really an evolutionary story. It's drawn from pretty much every user community that we've worked with and how they've seen the issues that they want an ELN to address. And these really fall into 3 successive steps. So the first step that most organizations go through is really wanting to document the experiments that they're conducting in the laboratory. This is really replacing the paper notebook, capturing the content that is normally captured within that paper notebook, but obviously doing it in a way that adds value over and beyond the paper world. So almost every organization goes through this need as they mature, think about other things, other bigger issues within the laboratory. There's often a need to think about how the structured numerical data is captured and managed and organized within the organization. Almost every scientific organization has structured data in this form. This might be assays in the biopharmaceutical world. It may be physical tests outside of the pharmaceutical world. But the nature of the data is pretty similar. Now this stage really sets up the third stage of this evolutionary path, which is now you have all that data. What are you going to do with it? How do you use that data, share it, combine it, and drive learning off of it, and really make the better decisions on where your science is going to go in the future? So these are the 3 areas that I want to discuss in a bit more detail. So the first stage in this is really around documenting the experiment, and it's exemplified by reducing or removing that Friday afternoons that's spent in front of the photocopier, photocopying content that's probably from electronic files, reducing it at 70%, and standing there with their scissors and the Scotch tape, literally cutting and pasting that into a paper notebook. It's really driven by efficiency. There's a lot of time spent doing that activity, and an hour or two knocked off of notebooking time per scientist in your laboratory can rapidly add up to multiple FTEs. If I was to summarize this world, it's really around capturing your data, whatever form that data is in, from very disparate types of science in a much more effective and efficient and accurate way than you can currently do in paper. So to illustrate this, what we're looking at here is a screenshot of a Windows Explorer pop-up. So we've selected a number of files. There's some images, there's a Word document, and there's a Prism file there. And we literally want to drag and drop that onto an empty experiment and have that content captured and displayed, presented within that experiment. So that's all very straightforward, and almost every organization goes through some level of needing to just capture unstructured data like that. As I said, as organizations start looking at the larger issues that they face, they start thinking about how they organize, how they manage their structured data. And as I mentioned, these are often biological assays in the pharmaceutical world. There may be physical tests, such as particle size distribution or rheology tests or luminosity tests or whatever tests in outside of the pharmaceutical research world. But the need is very similar. Now, in the pharmaceutical world, sometimes this has already been addressed. There's been development of dedicated test or assay databases that actually predates the development of electronic lab notebooks. So that need was actually understood before the need to capture electronically the unstructured data around the record keeping. Outside of the pharmaceutical world, this is often addressed with Excel. And one of the challenges with Excel is, if you think about when you build an Excel file to manage your data, you'll often use an Excel template of some kind and replicate that to put the data in. But ultimately, the rule sets, or the formulas and so on, that dictate how the data is processed and the data itself are in the same file. And as that test is executed multiple times through your organization, it becomes very difficult to look back and validate and qualify that the test or the assay was executed in the same way every single time. So it adds risk to your organization. So this world is really driven by a quality need to have traceability back that the tests were executed in a similar fashion every time, and you can compare like to like as you're comparing those numbers. So it's really around consistency of the way the data is captured and how the subsequent calculations are performed on that data. So I mentioned that in the pharmaceutical world, this has sometimes been addressed through the development of dedicated assay or test databases. So I wanted to talk a little bit about why ELNs are coming to play here in that world. So if you take your ELN or your lab notebook, in fact, including the paper world, this is the natural place for scientists to document their experiments. You know, why you're doing the experiment, how you're doing the experiment, and what you learn from it. If you think about the way the hierarchy of the data within that lab notebook, it's very person-centric. So as a scientist, I have notebooks, I have experiments, and I have the data organized within those experiments. The structured data, however, is on a totally different hierarchy. It's sample-centric or material-centric or compound-centric. So you've got materials or compounds, you've maybe got batches or lots of those, and then you've got the test types or assay types that you're executing on, and then you've got the data, which may be subdivided into some positional information such as plates and wells. And what would happen traditionally in the lab notebook world, electronic or paper, is that people would record the how, the what, the why, the where in their lab notebook, and they put the structured data within a dedicated test database. And maybe they put it in the ELN and then transcribe it over. So you'd have this superfluous transcription step, or else you'd have this separation of the data into two separate databases. So there's been a real push over the last few years to merge these worlds. How we've addressed this is to take our external test database and suck it directly into our ELN, so that from the scientist's perspective, they're capturing all of the information around their experiments in one place, the how, the what, the why, the where, and the structured data. But from an architectural perspective, this is a fully encapsulated database sitting inside the ELN, which allows us to have a different hierarchy. So to illustrate how this looks, here on the left we're looking at the rule set. I talked about Excel having issues with having the data and the rule set in the same file. So we separate them. The rule sets are created by users. This is really important for us that these are user definable, essentially as content within the notebook. You can see the hierarchical laying out of the data here. This is a sigmoidal plot IC50 calculation, but it could equally well be any other mathematical operation on a set of data. So here's our plates. We have compounds under the plates, we have concentrations under the compounds, and we have wells under the concentrations. And then we have a series of graphing operations and calculations being executed on that data set. The important thing about this protocol is that it has an audit trail, the same as our experiments, so you know who created that rule set and when they created it and when they published it out to the wider community. From the scientist's perspective, when these are created, the scientist just selects the rule set they're going to use to execute on and applies that to their data set. So here's a text file that's coming into the notebook. It's a 96-well plate format from a plate reader. And as that file is brought in, it can look up external databases for additional information, such as from the barcode of the plate to get the compounds. It does all the calculations on that data and does all the graph fitting. Again, in this case, it's a sigmoidal plot fitting, calculating the IC50 of these curves, but it could equally well be a particle size distribution or a flow test or any other test. So this second stage is very driven by quality, but it really lays up the third stage, which is how do you use that data? Now that you have it in a structured way that you can ask structured questions of it, how do you use that data to drive knowledge, drive understanding, and help you do your science a lot more effectively? So that's really this third stage, which relies on the second stage. And to summarize this world, it's the ability to bring data together, to ask very complex questions across multiple tests, across multiple assays, across multiple experiments. And this is why I wanted to challenge you to think about the problems, not necessarily the ELN as a solution, because to do this, you actually need to step outside of the ELN. The ELN is not the tool to ask these kind of complex questions. And to somewhat explain why that is, if we think about our ELN with our test database, that's not the only place we maybe want to bring data. We maybe want to bring data about uniqueness, about location from a registration from an inventory. We might want to bring information about samples from a LIMS. Perhaps we want to bring in some cost of materials information from something like SAP. And all of that data needs to be merged and tied together through the unique identifiers, the experiment ID, the sample ID, the registration ID, or whatever. And then that merged data set gets served up in our world to a best-of-breed data visualization tool known as Spotfire. Now, this kind of thing could be done historically, but it was very laborious. It involved the scientists going back and forth to IT and essentially having query language written to tie all this data together. It's been a very big challenge, a very iterative process historically, and one that's kind of impaired scientists from bringing new tests online and bringing them into the flow. But over the last year, we've really focused on making this a user-managed activity so that scientists can actually, through a series of mouse clicks through our applications, tile this data together. There's no writing of query language to bring data from our applications together and present it consolidated within the data visualization tool. So it removes that iteration with IT and makes it actually very effective to ask the questions that you want to ask. To try and highlight that, data is data and somewhat agnostic to the fields that it's coming from. Here's some visualizations from that tool spanning multiple industries. So here we have a classical omics view with our volcano plots. Here we have a dashboard from a QA lab looking at the progress of samples through a testing laboratory. Here we have a classical structure-activity relationship view from a pharmaceutical discovery lab where we're mapping physiochemical properties and biological binding properties against small molecules. And here we have a geographical view of some sample collection. So data is data, so it's very easy to use this across multiple industries. Again, to help you understand why the ELN is not actually the tool to do this visualization, if we think about where the data is coming from, in most organizations, there'll be somebody making something. It may be collected samples. It may be they're making small molecules, large molecules. It may be that they're making materials like adhesives or drilling fluids or lubricants or flavors or fragrances. But whatever they're making, somebody is making those in a series of experiments. So maybe once, maybe there's different lots of that. And then a host of scientists around the organization are executing the tests on that. They might be biological assays, they might be physical tests. But importantly, the data is disparate across many different experiments in the organization. And what you would need to do is cherry pick little bits of data out of all of these different experiments across all these different notebooks, across all these different scientists, across all this different time, and compile that within one visualization. So here's an example of that, again, from the pharmaceutical world, where we're bringing together calculated properties and experimental properties from multiple scientists and mapping that to the synthesized compounds in one single view. But many scientists are contributing to this one visualization. Now you can get really deep into the data mining there to help you drive your knowledge, but there's also a need to keep it simple and provide very, very digested content for people on the move, senior management, people that need a very quick and easy dashboard view into the data that's being collected around your organization. So again, here's an example from a QA lab where we're mapping the progress of samples through that testing laboratory, looking at which samples need to be prioritized and so on. And this is served up as a very simple but dynamically filterable dashboard within a web browser or even on mobile, so you can have it on the go. So I hope that through this presentation I've been able to challenge you to think not about is an ELN the right solution for you, but to think about the problems that you face in your laboratories that are impeding you from hitting your goals, from doing your science, and then how you might want to leverage things like an ELN and a broader informatics strategy to help you overcome those problems, starting with documenting your experiment and then thinking about capturing your structured data and learning from it. And I hope that some of this resonates with the challenges that you currently face. And on that, I'd like to thank everyone for their attention and pass it back to our hosts.
Thank you, Philip. And yeah, I think it's an interesting perspective and certainly very thought-provoking. So if any questions or comments based on Philip's presentation, please type it into the question box and send it my way. We'll certainly discuss it during the Q&A following all the talks. And also some of you have asked more about getting a copy of the slides. We will share with you the email addresses of all our speakers in our closing slides, so you will be able to reach out to them directly via email, and I'm sure they'll be happy to forward you the slides if you need them. So with that, let me welcome our next speaker, François Bellouen, who is a Senior Product Manager for the OpenLab ELN at Agilent Technologies. François has over 10 years experience in deploying ELN solutions for large pharma and biotech companies. And he's here today to talk about what it takes to successfully integrate ELNs into your current workflows. It's a real pleasure to have you back on our panel, François. I know you were with us last year, and welcome.
Thank you very much, Tanuja, and hello everybody. Thank you for joining this webinar. So in this short presentation, I decided this year to illustrate the integration strategy and challenges that most of you face or think about when you plan about long-term deployments, because we have now more than 10 years experience in the ELN deployments, and it's really an investment that you do for long term. So you have to think about how do you start today and how you see the future with your ELN deployment. So the agenda today will be a short introduction. We will talk about the fundamentals of architecture, and then I will give you advices about integration approaches and some examples, some scenario, and how you can connect different tools together. And I will briefly conclude with an overview of the Agilent OpenLab ELN. So why did I choose this presentation? Several recent lab informatics surveys and reports converge and indicate that the top data management challenges are clearly about how to integrate data from multiple systems. So that's really the top feedback that we get from users, from ELN users. A second report indicated the same, so the ability to interface with existing or future system. That's clearly how you figure out the next steps, and the ability to support different disciplines on the same technology platform. Second, but very important, is about finding what you need when you need it, and I think that was well reflected by Philip's talk before, and the importance of structuring data and finding data in your ELN systems. So let's talk briefly about the fundamentals of a powerful ELN architecture. So with current evolution of architectures and what we see for the future, clearly the architecture that offers the maximum flexibility is a traditional web architecture. So I don't want to go too much into the details, but just to remind what it is. So we have a different set of clients, which can be traditional computers, laptops, mobile devices that you can use from internet or from your intranet. Depending on how you are connected, you reach out your servers, which are, depending on the size of your deployment, maybe one or multiple servers that you then you load balance. And of course, data are persisted within the database, which also may be replicated for security and backup, depending on your strategy. So this is really the basis of a traditional web architecture, and we will see how you can benefit from each of the components of such an architecture to first deploy the ELN and then expand and connect different systems on it. So maybe before going too much into the details, I would highlight very importantly this slide, which is really avoid the spaghetti ball. So what we call the spaghetti ball is the result of years of integration. When you decide to connect a system one by one, you think each time what's the best and maybe the quickest way to connect a new system into another one. It's done like this, but in the future it really looks like it becomes a nightmare with time, because the dependencies you create between the systems make them difficult to evolve, and each one are too much linked with each other. So that's really the picture that you need to avoid. So the approach that we recommend is really the service-oriented architecture, so-called SOA, or loosely coupled architecture. So the idea is to think about each system and isolate them behind an API. API could be based on web services or REST services, depending on the technology you use. But the idea is to clearly identify a frontier between each system. And in the connector between each system, you can also implement kind of intelligent connector, which will make sure that even if one of the system is down, your ELN continue to work and is not 100% dependent on other systems. So that's really a great benefit over time, and each system can then evolve separately with time. So I've seen too many systems which were so much linked that you had only one choice, which was to replace everything or make such a big project to upgrade all the components that in the end it was a nightmare. So it's a really strong recommendation. Think about how you want to make each system evolve in the future, and take the time to design the interfaces well. So what are the steps I recommend to achieve that? So first of all, you will start by installing an out-of-the-box ELN. So depending on how you start, it could be very simple with 2 clients, 1 application server, and a database server. But by doing so, you already benefit from a lot of the generic ELN features that the system provides today, like the ability to centralize and secure data into one place, to be able to start knowledge sharing. So typically when people start collaborating on projects on the same site or different sites, or even between different groups, like a CRO working with its customers or vice versa, you can really start sharing information because it's in the same system. You also benefit from using the electronic signatures and also the routing of the workflow for the review. So you save a lot of time on that. Of course, you improve the quality of your data and you protect it well. For those of you who are in the research area, you can, of course, have the IP protection, which is much better handled by the electronic system than it was on the paper system. So the other benefit of such a system, because of the architecture, is that deployment to a new group is very easy. You don't have to install anything. You just create new accounts, give them the web link, and they can start after the training using the system. Same for upgrades. It's also think about upgrade the server, and everything will be automatically replicated on the client or downloaded automatically. And finally, if you compare this picture with the picture I had before about the traditional architecture, it's really scarce when your needs grow. You can really work on the server level, which could be database or web application, to increase the load capacity to make sure you maintain a good performance. So this is the step 1. It's a critical step, and once you've learned how to use the system, how it can be configured, you can start thinking about the step 2. So step 2 is really about configuring the system to meet your specific needs. So after you've learned how you can maximize the generic ELN capabilities, you can use the templating capabilities, and by template I mean the ability to build a configuration inside the ELN that will move away from a pure generic system to something that really fit a group of scientists' needs. So typically, if you want to design templates to support in vivo studies, or medicinal chemistry, or some of the QA/QC procedures, that can be implemented through the templating capabilities. And you've got these internal tools, and as examples here, you see that you benefit from the core features in each of the templates, whether they are from medicinal chemistry to analytical chemistry or QA/QC, or any other multidiscipline generic research capabilities that can be configured in such a way. So once you've done it, the third level is really now to start thinking about how you connect a system to another, or if the system that you want to connect or to create is something that does not exist. So the first step would be to build a new module. So how would you do that? Keep the existing out-of-the-box ELN intact somehow and focus on using APIs. So APIs can be at the client level, at the web application server level, or from database to database, but using again some layer to make sure you do not connect each of the database too tightly. So if you look at the top, and the client plugin is a way to extend a client component, which through the template, which is the UI, the user interface that contains the data logic, and the scripting will allow you to plug your configuration onto some services that you have built, which may be hosted in a reserved area, either on the application server or on the database. Another example, you may want to connect your template to an existing system. So you may have in-house applications, and you have many of them most of the time, which has its own database, its own server with an existing API. And then the connection here consists on creating the plugin which will make the connection between the application calls and the UI of the template, and then will let you interrogate or send data. Typically a registration system, you will send data from the ELN to the registration system, or vice versa, read from an inventory and incorporate some of the data into your experiments. In this other example, something I'm sure you face also in your organizations, you have legacy applications that do not necessarily provide APIs today, so are not in the right format. So in this case, you can focus on designing an extension at the application server level, which will recreate these missing API and make them available to a new plugin into your template. So as you can see, it's really important to make a study on what you want to connect, how you want to connect it, and check which schema works, and make sure you do not you always follow the same principles of using the right layers and interface. If you continue, today you can see more often the availability of cloud services. So is that the same story? Somehow, yes. You have on each cloud business services you may want to use, like the PubMed database, something like this. You can add a plugin which will route calls outside your network to these cloud services and bring back the information you need. So it's possible by sticking to these guiding principles. And of course, the combination of any of these mechanisms is possible. So with time, you will create more plugins, more extensions, more dedicated schemas, but by making sure that they can work well together, you will be able to upgrade one or the other without shutting down the entire system for weeks or months. So that's really important. So as a summary, how can you make sure you will have a successful deployment and integration with time? So it's important to look at the architecture. It's something that we often neglect, but that's key to support you in the long run. That is an ELN project. Think about the flexibility of the ELN. So make sure you can achieve what you want in terms of configuration and interfacing. This often goes through the usability of an SDK that will facilitate the development of the plugins I mentioned before. And of course, the method and methodology is really important to keep that under control, to avoid the spaghetti ball I was mentioning. So this of course, you can be trained. Your own IT organization can be trained. You can work with certified partners. Of course, you can also contact the ELN vendor. And what I see here is that for the very technical elements or the key integration, customers will use the vendor experience, and for the 50 to 60% remaining, they will use their own services or their own partners. So, as I was saying, a quick overview about OpenLab ELN from Agilent Technologies. So our ELN has really been designed to address multiple disciplines. So it's a multidisciplinary ELN which can be adapted to the different disciplines, of course, through the templating capabilities. So template can mean, a user interface to design, to support analytical chemistry or QA/QC or biology, but also it consists of the repository of protocols, SOP that can be given to the users. The workflow capabilities are really important and are key. We have really put emphasis into making sure the collaboration capabilities and the workflow reviewing capabilities are really fitting how organization works. And in the end, it really saves a lot of time. We see that the ability to always be notified when something happens, to have a quicker access to what you have to do in terms of analysis or reviewing is always a key away, and that's important. So the architecture scales well. So we have some small deployments to large deployments, and it's always the same system, the same architecture, just focus on how many application servers you may put in the backend and size the servers correctly. So we keep a very important focus on the IP protection, the data quality and traceability, and to really make sure that people can use the system as a collaboration tool, because this is really the key direction that we see for ELNs. So I would like to ask you to, if you're interested, to visit our website. So you can go to the openlab.eln.chem.agilent.com website. It's you will find information about the product, and you can also try the product, as we have a version in the cloud it's free. So don't hesitate. Create your account and try it, or contact me by email if you have further questions. So thank you for your attention, and looking forward to the questions.
Thank you, Francois. I think already both the talks have generated a lot of questions from the attendees. So please bear with us. We will go through our final talk, and we will be able to address your questions right after that. Our final speaker today is Dr. Thomas Schmidt, who is a Senior Product Manager at Waters Corporation. He has worked for Creon Lab Control, first as a software developer and later as a product manager. And the company was then acquired by Waters Corporation. So Thomas's focus is now on the development and deployment of the new Genesis ELN for analytical laboratories. And his talk today will go over some of the critical elements that are necessary for implementation of ELN. Welcome, Thomas.
Okay, thank you, Tanuja, for your introduction. Hello to everyone, also from my side. Before I will talk about the topic of today's webinar, please allow me to provide some background information about Waters Corporation. Waters Corporation has a more than 50 years lasting history in the laboratory business, and it's the leading solution provider for LC-MS and UPLC technology, but also in the laboratory informatics domain. And the informatics portfolio includes applications such as Empower, the market-leading chromatography data system, but also the Waters Genesis 8 platform. And this platform comprises the Genesis STMS for data management and Genesis ELN as a workflow component. The title of this webinar is, Do I Really Need an ELN? I think that's an interesting question to be answered by an ELN product manager. And my answer is, no, you don't need an ELN if the sample turnaround time in your lab is not that important, or if you have enough lab personnel to run your samples and you have satisfied customers, or if you don't have to respond to competitive or regulatory pressures. But if only one of the aspects I just mentioned are an issue for you, or in other words, that you would like or you have to increase the efficiency of your lab, I'll be happy to talk to you about the rationale behind an ELN and the potential consequences an ELN deployment has. Here you can see a workflow example of a typical laboratory procedure. Not all procedures, you know, are that complex, but some are even more complex. And the example here, it's actually a chromatography-based dissolution test, is even simplified since it leaves out the fit-for-use checks for all the small lab devices, balances, pH meters, that might be applicable for the preparation of the solutions, and along with their calibration and verification prerequisites and instructions. But regardless in which industry you are working, the analytical labs share quite common problems. Whereas the methods, the analysis methods may vary, the overall daily routine in the labs is quite the same. This means you have to deal with incoming samples that you have to test. You have to manage your instruments and your consumables. You have to perform the tests, collect the results, and report them back to the originator. And this means you have also to take into account sample management, inventory management, and data management aspects. But are we then still talking about an ELN? Yes, we do, and let me show you why. Let's bring this into the context of the whole laboratory operation. The lab operation is quite complex, and as a lab person, you have to deal with a variety of tasks and issues. And some of the issues are science-related, and some can probably be attributed to operational shortcomings, and things like manual transcriptions due to the number of different IT systems that are only one aspect. For example, we saw that sometimes you have to enter the sample ID 5 or 6 times again and again in the course of only one analysis method. And it's obvious that the more complex and higher the number of systems is, the higher is the chance of an error. But when you want to optimize the efficiency of your lab operation, you have to take 2 major aspects into account: the lab process itself and the supporting IT environment. To simplify the lab process, you could, for example, apply the principles of lean management. Lean management initiatives, these are focused on determining the non-value added steps in your processes, and this can result in efforts to minimize the expensive peer review processes. So for example, by eliminating manual result transfer processes. And here is where the IT solution comes into the game. So we have to regard solutions that support the people at the bench, but also to take into account the business aspects, or call it the big picture. And of course at Waters we are very aware that it's really critical to have only not the technology, but also the service and the support to deploy lab applications even up to the global scale. But to lower the training needs, the deployment and validation efforts, and also to lower the associated costs. How does then an ELN fit into this picture? In the past years, ELN have transitioned from pure documentation tools to comprehensive laboratory platforms. And on the one hand, this can be attributed to the new functionalities ELNs are offering nowadays, such as inventory management capabilities or sample management. But on the other hand, you have of course the increased abilities to integrate with other existing systems. So for example, business applications such as LIMS or SAP, or systems like instrument software. And therefore, the ELN can really act as a portal for the entire lab operation. And this means that you can now move from perhaps a scattered or delocalized analysis process into a single transparent online workflow. And with the appropriate ELN, this means you can track the entire analysis process, the samples, and the results at all times. But when we talk about an ELN, it's of course not only about features. I think even more important is the user experience. And this is so important because an ELN in the analytical lab is in the first place a tool for the user at the bench. And of course this must be reflected in a user-centric design, and especially when you have to migrate from a paper-based workflow to an electronic workflow. You must ensure that the transition is as smooth as possible for the user so that they can achieve their tasks in a very convenient way. And the user should not be overwhelmed with all the nice features an ELN has, because they must be able to find easily the information they're interested in. And this is regardless of their role, if they are an analyst or a lab manager. Here you can see an example of how an ELN actually can serve as a portal for the lab operation. So from here, users can access their current work, but they can also get an overview about the entire work which is currently going on in their laboratory. And you have personalized dashboards that give you a fast indication of the work status, and they allow also to directly access the corresponding activities. You can also directly access data of other systems, such as the Empower CDS, or from other instrument systems via the STMS repository browser, or if you want, you can manage also the integrated instrument and consumable inventories. When you want to implement actually an ELN, I think you probably will start not from an empty ground. And so the IT projects we see today, these are no longer just pure ELN projects. And I think when you just look at your requirements, I'm sure that besides the documentation aspect, you have also requirements dealing with sample management, inventories, and of course data management. And then the discussion starts. Should you look for a best-of-breed solution? This means a specialized solution from different vendors for ELN, perhaps a LIMS for sample management and an STMS for the data management, or should you look for a single platform solution? And the answer is, of course, it depends. Let me give you an example for this. So if you already have a LIMS in place and you want to switch from a paper-based to an electronic test execution system, I think you should not replace the LIMS, even if the new platform has sample management capabilities. But on the other hand, if you want to connect a business system, such as SAP, to your lab, and there is clearly a need for the sample management at the bench, then you should definitely consider to take advantage of the sample management capabilities of the ELN platform instead of implementing an additional LIMS system. And when you have to implement only a single platform, the implementation is of course much easier. But whatever you choose, your system should be highly integrable into the existing IT, but of course also into the lab environment. Before you start implementing an ELN, and by the way, that applies to all systems, you must collect your detailed user requirements. This is really important. And because otherwise you have no evidence afterwards if the system actually fulfills your needs. And then when you start deploying an ELN, you should consider certain things. A good starting point would be to think about your data first. What are your data sources? Which information, which part of the data is actually relevant for my decisions, and perhaps also for being compliant, and what are my storage and archiving strategies and needs. And then, of course, you should standardize the process. And with the help of an ELN, you can make the processes more reproducible by using, for example, experiment templates. And typically you have a lot of processes and methods in your lab. But what you should do is you should refrain from implementing all test methods electronically in one shot, because this will lead to a very long implementation time. A good approach is to focus first on the most strategic aspects, perhaps when you work in a quality control environment, on the most strategic products, or when you work in a development environment, on your most important methods. Because this will give you already a big win at the beginning of the implementation. And then, of course, it's also imperative to integrate the data management part with the ELN, because this really avoids manual transcriptions on the one hand, and on the other hand, it provides you a complete traceability to the original data. And finally, of course, it's important to connect also the business systems to minimize also the transcription time and also the errors. So when you decide that an ELN would be beneficial for you and you're looking for a state-of-the-art ELN, I think we are not talking any longer about a pure electronic documentation tool. I think we are more talking about a laboratory platform. A laboratory platform with which you can really increase the workflow efficiency, because it can serve as a single point solution with a lot of integration capabilities. And by standardizing the information management, you actually can reduce the waste and the variability in the laboratory. And since it has an integrated database, it provides also a quick and easy data accessibility. And finally, you can manage the data flow between the lab and the business system and really connect the science to the business. And when you make a decision about what ELN to implement, I think it's good not to make a decision for a system just because it has the most features, because most of them you won't use anyway. So look at your requirements and then choose a system that best suits with your requirements. And you should also not make just a decision purely based on the price, because if someone, perhaps your manager, or even more important, someone from a public authority during an audit asks you, why did you choose this system you're using? I think then your answer should definitely not be because it was the cheapest one. But then your answer should be, we have chosen it because the system is the one which has the best fit with our business needs and our IT requirements. With this said, I would like to thank you for your attendance in this webinar and your interest in the ELN topic. And if you have specific questions, perhaps to our ELN solution, don't hesitate to contact me directly. Thank you. Tanuja?
Thank you, Thomas. Very nice talk. And let's get to a number of questions that have come in. I'll try my best to, ask each question as it has come in, but I think it might be more effective just to kind of group them together, because the questions have come in specifically around certain big issues. And so let me try to group those questions into the bigger issues, and let's try to address them as an issue first, and then if there's time, we can get into the specifics. So let's first tackle the issue around customization. I think a lot of questions have come in about how customizable are these ELNs? Can you do custom data processing? Can you actually export charts to pictures? Can you design reports that are specifically meant for my application organization? Can you pull data together? Can you merge them together? So as I said, can we just address customization in general, and then of course if there's time we can come back and address each of the specific questions. So who wants to take on the customization topic and talk about what can and cannot be done?
Yeah, this is François here from Agilent. I can try to start giving a few elements. I think the customization, as you describe it, with the ability to capture data, merge data, then extract data, is really about thinking about what you want to capture, and I think that was covered by the different talks today. So first, think about the information you want to manipulate, structure it in your ELN, and today ELN can do that. I would then not necessarily think that the extraction, the reporting, and the data trending and so on is necessarily done into the ELN. There are also statistical tools that can do it well. So it could be included, some of ELN provided. But what is really important is to make sure that you are able to extract information in a structured way, so that if you don't do it into the ELN and you want to use your own reporting tool, then you can bring the data out of the ELN, and it's all about APIs and export capabilities.
Mm-hmm. Okay.
I would like to add something. This is Thomas from Borders. To be honest, customization is always a quite delicate topic when deploying an ELN. So on the one hand, you can say that you should avoid customization because it definitely would lead to a longer implementation time. What you should try to achieve is to choose a system which allows you to meet your needs with via configuration, not customization. But on the other hand, this is not always possible, and the ELN should have an open architecture which allows customization. But when you look at customization, you should take care that the customization would not affect the core system, but that the customization modules can be, for example, attached via plug-in approach or via web service approaches.
Okay.
This is Philip. I'd like to add to that and maybe just qualify a little around the syntax. Thomas just talked about configuration. We tend to talk a lot more about configuration than customization, and the differentiation between the two comes when you start to write code. So anything that a system admin or a super user can do simply by mouse clicks, we call configuration, and we're proud of the high configurability of the product. Anything where you actually have to go into the code and write new code, then we call that customization. The gray area, which probably lies more in configuration, is if you need to write something like SQL to pull data together. But as I hope I illustrated in that presentation, when you're starting to talk about pulling data together from different places and presenting it in some kind of report or dashboard, and that's been a big focus of ours in moving that from the SQL query world to where users can just do that with mouse clicks. It's a really important thing to us. As some of the other speakers mentioned, stepping outside the ELN to do that is important, but the ELN really helps be the vehicle to bring the data in the right way that it can be pulled together in some kind of report or dashboard, dynamic or otherwise.
Sure. No, that's all really good feedback. The other big issue that came up in terms of the questions is around integration. So there have been a lot of questions like, can ELNs integrate with PCR? Can ELNs integrate with LCMS type data? Are there any types of instruments or data that they cannot integrate with? Can ELNs integrate with some of the ERP packages that are available? So can you talk about what can and cannot be done in terms of integration?
Yeah, I mean, this is Philip. I'll take the lead on this one. I challenge the audience. We often hear, can your ELN integrate with X? And the short answer is yes. But the long answer is, in partnership with you, we really need to sit down and understand what that integration looks like. How deep into the data does data need to get passed back and forth? So we routinely integrate. We have integration with a lot of our own stuff. We have ability to integrate with both instruments and other systems. They tend to be one-off because one organization's view of what that integration should achieve is different to someone else's, and we would always challenge to think about the problem before you think about the solution here? What is your current lack of integration impeding you from doing, and what would you like that integration to solve for you? And then, part of what we also like to do is, sometimes when it comes to instrument integration, there's a big focus on getting the data off of the instrument and into the ELN very effectively. And often when we uncover a little bit deeper, that's not so much the challenge. The challenge is more on the back of bringing that data together with all the other pieces of data. So having a consistent format of the data coming in, having an easy way to put it into the ELN is important, but being able to pull it together with all the other data, and if that's sample tracking for process through a testing lab, or whether that's a discovery, question and answer scenario, pulling all that data together is actually the bigger issue than having a button that goes to your LCMS and pulls the data, for example.
Okay. Francois, Thomas, your thoughts on integration?
This is
Well,
Thomas
yeah.
from Waters.
Okay, please, Thomas.
Oh, thank you. Sorry. So I think integration is, besides the documentation aspect, the biggest aspect in the ELN world. Because originally the ELN was just the replacement of paper. And I remember last year Francois called it paper on glass, right? But this has changed dramatically. Actually, an ELN nowadays is a focal point of integration. And you already mentioned some aspects, Tanuja, in your question. So it really, an ELN is nowadays supposed to cover the entire laboratory process. And this starts when the sample comes into the laboratory, which means a connection to the ERP system, goes along to the connection to even small lab devices, balances, and so forth, because this is the most critical component, or a very critical component in the whole laboratory process, goes to instrument software, and even more to the long-term archive. Of course, I think the vendors have also a learning curve, because there are typical systems throughout the industry which are very widespread, and then once you implement an interface to one of these systems, this can of course be reused by other systems or can be added to the core product, and so really you will have a high integrated system into your laboratory environment.
Sure.
Okay, so let me add a couple of things, but I think you both cover the topic. As you said, I mean, you can always say yes, integration is possible. It's always, finding the limit between configuration, customization, and it's also a lot about structuring data, because you may say yes, I can integrate with an LC system, for example. So what does it mean? You can get the PDF report into your ELN, but it's not sufficient. Then you cannot really reuse the data which is contained into the PDF. So it may be better to consider incorporating the XML output, or maybe an Excel report, and you can more easily extract data from it and reuse it into the experiment report to make conclusions, or to extract that for trending or further reporting capabilities.
Okay. Well, here's another interesting question, which is a different aspect of integration, if you will. Do these ELNs actually talk to each other? Say if you have a large company where different arms are using different types of ELNs, do these different ELNs actually, can they be integrated?
That's a very nice question. So actually, I mean, we are talking about the ELN, but we have a lot of domains, right? So we start in research and development, and this goes over into manufacturing, right? And for sure, you cannot use any ELN for any purpose, right? So you might have, on the one hand, the medchem ELNs, which might be used by scientists, and on the other hand, you have ELNs that serve the analytical service labs. And of course, these ELNs can talk to each other in a way that, for example, the MedChem ELN can send a request to the analytical service lab to another ELN. Another important aspect is when you go in the pharmaceutical area, for example, perhaps also in other industries, from development into manufacturing, right? So we are talking about method transfer. There's always a discussion point, even having the same ELN or using different ELN with the price of transferring the methods. So there is not the right answer at all, but there are a lot of discussions and possibilities around these things.
So are the vendors working towards making something like that happen? Because I guess the users are demanding it. There's another question here that's kind of along the same lines, where could there not be just one set of software that designs modules that gathers and integrates data seamlessly through all of the biotech pharma processes, you know, like a SAP for life science package?
Yeah, this is François from Agilent. So there had many initiatives in the past in trying to standardize the ELN formats or ELN experiment formats. So obviously none of them succeeded to date, and it's true that with many different ELN vendors in the market, many different software, you know, you generate different different databases, and it's quite hard to consolidate and integrate the resulting data. So what is important, I would say, is to pay attention to the format, the export format, the output format from the ELN. How easily can you move data out? Or if some of you have already been through the migration, it's something that then you may also pay attention to. You know, how you can extract data, how you can import data, and that can help. But there is no de facto standard to exchange data from one system to another.
Okay.
Yeah, this is Philip. I'll add to that. You know, the short answer is really not, certainly not between vendors. And you know, as Francois just alluded to, you know, there's a lot of different vendors, and there's no common standard, and it's you know, you're balancing that need for the vendors to have the innovation to create things as they will and respond to what the customers want, and not be constrained by the standards or any standards. I think that's why these efforts have failed. Again, I'm really big on sort of ELNs and LESs and so on are tools to solve problems. So looking at the problem and looking at the workflow that occurs, and I think the interplay, and you know, Francois talked about this as well, is really between, say, the research or the development side, and then which is much more user notebook centric, and the QA side, which is maybe more sample management based. So where those often ELNs don't work in both spaces. I believe Francois was suggesting that they have a solution for both ends of that. We have a solution for both ends of that, and we do have integration between those two, so that from the research-centric side, or the development-centric side, you can submit sample lists that are then executed in what's more of a lab execution system, and then have those results brought back. But I think it's a lot easier for organizations to integrate with their own stuff than everyone else's. And I think, you know, there's so many different players in different pieces of these places. Some organizations want a single vendor. Some organizations have maybe 2, 3, 4 different ELNs inside. So understanding, you know, what needs to be achieved by that integration is different from customer to customer to customer. And that's why a lot of these integrations don't exist currently, because there's too many permutations there to manage.
Well, hopefully we'll be there someday. I guess if enough people demand it, it will probably happen. All right. The other big issue that has come up is you know, around the legacy data, and also around security, cyber security, backups. What happens when your ELN fails? So let's start with the legacy data first, and then get into more of the security and the backup issues. So what happens to all the legacy, the paper-based data once your electronic system gets deployed?
Yes, Philip, I can jump in on that. I mean, it really depends what you want to happen to it. Some organizations just park it. It's a prior life. Some want to incorporate it within their ELN, so it's searchable. You know, the good middle ground is probably to scan it and do some level of optical character recognition and just incorporate those for text searching. You know, to create those paper ones as electronic records can be probably cost more in time to make that happen than you'll actually get value from it. But if the data is more structured in files, then there's ways to do that. There's also a question around legacy of, you know, we had a certain ELN and it's getting discontinued. So we have had very successful migration projects from other ELNs. But when the data is on paper, there can be a lot of effort involved in getting that in. With respect to security and you know, servers going down and backups and so on, you know, these things are only as strong as the weakest link in the chain. So, you know, the ELNs generally come with good security. They come with, you know, user credentials and passwords, and you can put in PKIs and so on to help authentication and so on. But they rely ultimately on how strong your policies are internally, on having unique passwords for the users, having security within your firewall, for example. Likewise for backups, it really depends on whether your organization backs up the servers. If your backup policies are not strong, then you add risk to the organization. One thing that we do add to help that is we do have an offline cache that's local and encrypted that allows people to work when the server goes down, if it ever should do, either scheduled or unanticipated. And that's been used very effectively at times in giving people the ability to carry on working while the server's been offline. But ultimately, both security and backups rely on, you know, how strong the internal policies and practices are at the organization. And if anything is going to be the weakest link, it will be, you know, people sharing passwords or people putting in holes in the firewall or something like that.
Okay, so you're saying that security is more on the user side and it's less of an issue with the software per se.
All I'm saying is that, you know, it's not just the ELN itself. It's a chain. So the strength of the chain is dependent on its weakest link. I'm confident that both ours and the products of my colleagues or my co-panelists here are built incredibly strong with respect to security and enabling backup procedures. So adequate implementation of good policies in the organization is critical to make sure that that part of the chain is equally strong.
That's
absolutely, yes. This is François, and I really am in light of what you said. So of course, if you consider, all large farmers have implemented ELNs and put their critical data into it, so it's a good sign. But also, you're right, you have to make sure, and I would say it's up to the IT organization with the advices from the vendors on how to configure it. But here there's no magic in it. It's really something which everybody does. It's about backing up databases and making sure that you test, that you can reload a dump. That's really standard procedures that exist and that work well. So you should not be worried about that part. And then there is a part at the end user when, of course, the policies as Philippe described have to be followed, and users should not share passwords and so on. But that's about accessing data, but it will not damage the data itself or put risks on the overall data integrity.
Sure. sorry, was it Francois? Who?
Yes, that was Francois.
Yeah. So Thomas, did you have anything to add to that?
Yeah. So I mean, concerning the legacy data, I fully agree with Philip. So you can either integrate, let them as they are, or migrate, and so it also depends on the domain where you implement your ELN. So for example, if it's very important to share knowledge and you work with your legacy of chemical structures, you might tend to migrate the information into your ELN. When you work more in a regulated, perhaps manufacturing environment, then probably you use ELN implementation as a new starting point. And for the security, I mean, it's the same as when you, how you have to deal with regulatory, rules. So there are the rules, but you must have the procedures to comply with these rules. And if you comply with these rules, then there should not be an issue with the data security.
Okay. Well, one of the questions is, you know, the trend now is to be able to share data across multiple sites, share data with different colleagues, be able to, you know, pull data from multiple sources, and also make things available in some open source format, especially if you're in academia. So then the question is, first of all, can ELNs help you do that? And if you can do that, are you in some way compromising your security? And what can you do to minimize those risks?
Well, this is Francois. That's a key element that I also put to my presentation. But one of the major objectives of ELN projects today is to collaborate, improve collaboration, and share information. So that's really key, and ELN allow you to do that today. So yes, you have to look at how it works, how you can configure the access to a set of data, a set of experiments, depending on where you belong to. It could be a lab. If you are inside a project, then you can also define the rules for that project. And so the ELN must provide you that flexibility to configure the visibility of the data based on the lab you belong to, or the project you are working on, or any other group information that you want to include. So that should be built in, and it's something you can look at carefully when you do a pilot or you evaluate the system.
Okay, thank you.
Yeah, this is Philip. I mean, I think the answer to that question really depends on what people are trying to achieve. There's a scenario of sharing, say, the notebook experiments, for example. But generally, most people, when they want to share them, they're sort of combining experiments, the best methods, and maybe reporting. I mean, the standard route is out into the literature, and being able to get out a flattened version, a PDF or a Word document or something of that experiment is maybe a useful route for that. When it comes to the data, so for example, you maybe want to bring together a table of all the different compounds and then a number of different properties of those. That's data that's been extracted from various experiments. The ELN helps get that data in a structured way, but you need to step outside the ELN often or to effectively pull that data together. So we use Spotfire for that. Spotfire allows you to talk to the databases on demand, but you can also save your data set as a fully encapsulated file and publish those. So we have we have ideas and discussions around sort of more academic or publicly funded organizations that when they have that processed data where they've elucidated their trends and they've pulled the relevant data together, that gets served up into the public domain. And I think that's something that's going to become more and more interesting. But that doesn't have the links back to the original database anymore, so the internal security is maintained.
Sure.
I guess it's up to the organizations to control, if you're publishing stuff to the public domain, that what you're publishing is appropriate to publish to the public domain. So there's vehicles for doing that, but I think most organizations would want to have some kind of check on what's published out.
Absolutely. Yep. All right. Anybody else, or should I move on to the next question?
So I think the aspect which was not covered here is the common data formats. So, I mean, it also depends on where you are working, in which domain. So, for example, when you want to submit information to the FDA, electronic submission is now strongly supported. You need the way to provide data in a public format, but also I think the trend goes away from just including pictures into the ELN, but the scientists want really to work with the data to zoom in, perhaps to reintegrate and so forth. And this leads to the support of public standards like JCAMP or Animal starts also spreading.
Okay. All right. Well, this question came up last year. I think it came up the year before when we discussed ELN, and it's come up again. So I guess it's worth a discussion. Why do we need ELNs and LIMS? What's really the main difference, and can we get by having one or the other?
So the biggest difference between ELN and LIMS, a LIMS is a business application. An ELN is a tool for the people at the bench. And we saw even customers who had LIMS and ELN, and we asked them for their favorite feature in the ELN, and they told us our #1 priority would be to see where my sample is, because people don't want to switch between LIMS and ELNs just to get their status information and to get their instructions and to get their limits. So a LIMS typically is concentrates on numbers, and an ELN on procedures. And so you see nowadays a lot of efforts also from LIMS providers to integrate with instruments, but then you still have the documentation gap, right? How do you document your sample preparation? How do you document your instrument calibration? And of course, there are a lot of interfaces on the market between LIMS and ELN systems. But again, the original intention of these systems is completely different.
Okay.
Yeah, this is Philip. I think Thomas there is absolutely accurate in his delineation between LIMS and ELN. The only thing that I'd really add to it is purely syntax, but kind of what we're moving towards is that in that scenario, it's the interplay between a LIMS and what Thomas described we'd call a lab execution system now. Our feeling is that a true ELN probably lends itself much more to sort of experiment documentation, and the LES, or lab execution system, is around that instrument calibration. It is around the sample prep. It is around tracking your samples where the LIMS holds the numbers. There's definitely gray areas between these products, and there's significant overlap. So the decision, for example, between an LES and an ELN is very clear. If you're in a QA lab or if you're in a discovery lab, but as you start to be sort of somewhere in between, it can get a little gray. This is why it's really important to sit down with the vendors you're looking at and discuss what you're trying to achieve, rather than just asking them to come along and give you a demo.
Sure.
It's really important to understand the scenario of what your problems are. But yeah, between a LIMS and an ELN, or between a LIMS and an LES, it's really, they do fulfill distinct roles. They are complementary to each other.
Mm-hmm. Okay. All right. I think we have covered most of the big issues that came in, and I apologize to the attendees. There were so many questions, really, and thank you for that. So I was not able to get into all the specifics, but what I can do is, we can definitely forward on all the questions to our 3 panelists, and they will, be able to reach out to each of you on an individual basis and try to address your specific questions. But as I said, it was interesting to note that customization, integration, data sharing, security, all these are still at, on the top of people's minds when they are looking at ELNs. Here's a question, can ELN be designed for operation purposes, such as ESH or, for authorized lab user lists, etc.? Kenneth?
This is Philip, and my honest answer is I don't know, and I would need to take that question to one of our team that's more specialized on that area of the business.
Okay.
I would anticipate yes, but that's a qualified yes that I would really need to ask one of our experts in that area for a true answer.
Okay.
But I can get back to the questioner around that particular subject when I've checked in internally.
Okay, we'll be happy to forward that along to all of you. Francois, Thomas, do you have any idea whether your ELNs can work for operations purposes? If not, yeah, if you can take the time to get back, not only to the person who asked this question, but as I said, the other questions which were sort of along those main groupings, but more specific, on more specific issues. So I think we have almost reached the end of our webinar time, and we have covered all our main important categories. A quick note that the webinar will be archived on Lab Manager's website, so all of you can certainly go back and listen into the discussions. Just remember, you will not be able to download any slides, so you will have to contact our speakers, and the contact information, the email addresses of our speakers appears on your screen. And they have offered to help you address your questions, forward your slides, so definitely reach out to them. On behalf of Lab Manager, I would like to thank all our in Elmer, Agilent, and Waters for their participation and support of the event. And my sincere thanks always goes out to our speakers, because it's a real challenge to pack in all that information into 10-15 minutes, and to present it in a way that's useful and relevant to the users is much appreciated. And finally, a big thank you to all our attendees for taking the time to join us. Your questions and feedback really made today's event a truly open dialogue, and it has made the event very lively. So please take the time to join us again. And for the details on our next webinar, check out our website, www.labmanager.com. Until next time, goodbye and good luck.